Expectations for mobile applications have gone steadily up since the iPhone was first released, but the choice of databases built for mobile apps has remained limited mostly to SQLite. RealmDB was created as a new option for mobile developers on iOS, Android, or other mobile platforms. Realm is not just a database, it is a database platform offering a variety of systems such as authentication, sync, and an event framework. In this interview with RealmDB VP of Engineering Brian Munkholm, he explains why we need not only a new mobile database type, but an entire database platform. We talk about the business of mobile, IoT, cloud, and cross-platform. It's a wide-ranging conversation, but also deeply technical. As applications become more distributed and sophisticated, managing and maintaining them becomes more challenging. Running one of the world's largest PaaS platforms, Heroku understands the value of operations and the opportunity cost of developer time. Listen to the live podcast with Heroku Engineering on February 28th to learn about Heroku's metrics platform architecture and how it laid the foundation for autoscaling. We'll talk about the importance of maintaining application health and best practices for monitoring application user experience. I love Heroku both as a user and because they are a sponsor of Software Engineering Daily, but I want to emphasize that I do use Heroku in my own projects. So I really am a fan, and I'm looking forward to doing some continued episodes about Heroku. Brian Munkholm is the VP of Engineering at Realm. Brian, welcome to Software Engineering Daily.
Well, thank you very much.
The expectations of mobile apps have been going up since mobile started. And at the same time, mobile apps often don't meet those expectations. How have those expectations about mobile apps changed, and why is it difficult to meet them?
Yeah, well, it's amazing to think back on how quickly things have actually gone with the mobile apps, right? Actually, when we started in Realm and we were talking about doing a mobile database, a lot of people, including the investors, were sort of quite dubious whether that would be any good idea. Because even 5 years ago, mobile apps were not really a big thing yet. So it's really been quite an amazing and high-speed race to getting some apps that works. Now, the problem today is obviously that, that development has only taken place over the last couple of years and really accelerated here the last few years. And it just seems like, the technology is a bit immature, and that's pretty obvious from the few years that it has taken to develop it. And therefore, there's a lot of, complications in making apps. And some of the technologies are just not mature yet. So there goes a lot of components into making it, yeah.
Yeah, it has been interesting seeing the contrast between the pace of web development and even mobile web versus the pace of native app development.
Yeah, it's true that a lot of things has happened there, and I think in particular for some of the smaller companies or even indie developers, they are actually now competing with the biggest corporations in the world that has endless resources to put into app development. Because now it's gone, everybody uses the big apps from Google and Facebook and whatnot, and therefore the expectations are just that things works. So they do, pour in endless resources into app development, and obviously make some good stuff, and that just becomes the baseline of how people expect apps to work. And if they don't, then people get disappointed. So, and because it's so hard to do, it requires a lot of resources from people, and therefore, the best thing we think we can do is actually to try and make that a lot simpler. So that's basically our mission.
Indeed. So Realm is trying to build the perfect backend for mobile apps. What are the backend challenges that are unique to a mobile application?
Well, the unique thing is that you don't know if you're online. every time you have for many years we've been dreaming about this situation, or where you're just always connected, and that's a promise we've heard for many years. But the reality is just that that doesn't happen, and it will never happen. You can go down to San Francisco, or you can go to a metro, or you can go into a supermarket or whatnot, and you won't have a connection sometimes. And that's just also a lot of latency. The mobile networks weren't built for this originally. So it is the communication between a mobile app and the backend is just very different from the expectations and you have with a desktop computer and a browser, where you know that you're always connected, right? And if you're not, nothing works. Now the expectation is today with mobile apps that things works whether you're connected or not.
Realm is this offline first database. There are many mobile apps like Facebook or Netflix that are online first. There's way too much data in these applications to keep everything on the phone. Explain what offline first database means and how that contrasts with these companies where you have to be online to use them.
Yeah, well, that's the offline first thing where obviously, I was taking a plane ride actually from Copenhagen to San Francisco here not too long ago, and I was sitting in the plane and I came to my mind that I have some few tasks here I need to remember when I land. So I took up my phone, I started up my task app, and I don't want to say what name it was, but I was just so disappointed that I couldn't add a simple task in my task list. That was just stupid. And obviously a task list is one of the first things where you would expect it to be available offline and then connect and then sort of sync up, right? And that just doesn't work. Or when I go to some city, another country where I don't have a mobile data plan, because first of all, that's expensive, and second of all, I won't have it immediately when I land. Then, I try to go into to my Google Mail to look up the address of the hotel where I'm driving. And the first thing that happens is, obviously I'm offline, and even though I've been searching for that hotel before I left Copenhagen, I can't even get the address of my hotel. That just sucks. So, it's offline is also about, or offline databases is also about, having things available that you used to have either when you're totally offline, or even if you are online, to give a superior user experience. Because the moment that you have data available on your phone, even if you're online, right, and you don't have to make that request to the server, you just get a much faster user experience. And the thing is that, from when we've been sitting with our desktop computers and accessing the web, we've sort of gotten used to delays. We've gotten used to things, takes a while. But the expectations from users changes completely when you have things in your hand that you touch, because you expect it to be live. You expect, if you move your finger, you expect things to move. You can't wait 2 seconds before the thing moves around, right? So the physical device there just changes the expectations and the requirements basically for all apps to be real time. Yeah.
Yeah.
Let's take an example of, you have a map, right? You zoom in or out on that map, and you see all your hotels or whatnot, or gas stations, and the minute you just zoom out, you don't want to wait 2 seconds for it to populate the things that are now available on your map, right? So you want that available immediately.
Let's talk some about the engineering solutions pre-Realm. What are the backend solutions that people have been using on mobile apps for a long time? I know there's SQLite, there's some other solutions. How well do these satisfy the demands of the modern mobile application?
Yeah, well, we found out that it didn't at all. So that's obviously why we thought we needed something better. Because you say there's SQLite and others. I can really only SQLite comes to my mind, as something that has been built for an embedded system anyways. And when we started out, it was Like at that time, we've seen, a NoSQL database popping up every month, right? So much happened server side, so much innovation on databases happened server side. But meantime, on mobile, nothing has really happened since SQLite, for 20 years ago. And the problem is not so much, the technology as such. It's more also the APIs that you have available as a programmer, right? I mean, SQLite is great. It's a great technology, no question about it. But it just doesn't provide. I mean, it wasn't built for modern software development, and especially not mobile. So we thought, okay, what will it look like if you really started from fresh, clean slate, and you could really build what you want? Because what happened was that, with SQLite, I don't know how many hundred ORMs has been built on top of that to sort of band-aid, what you really need. A modern object-oriented API that actually works like it was built for your language instead of, a big impedance mismatch between your programming language, your objects, and then just a lot of copies of data. So nothing has really been built, from scratch to solve how to deal with data in a programming language, not for mobile at least. And some of the differences in mobile is obviously that you have some limited space, you have some limited capacity. CPUs are a bit slower, although you can say these days it's really, really powerful actually. But there's still low-powered Android devices around in the world, and those also need to be served, right? So something that is built for small data, for being super efficient, and also for something that actually are quite efficient and fast. That was something we started out with. What we then realized, talking to users, was that their biggest problems was the ease of use.
You are building a data-intensive application. Maybe it involves data visualization, a recommendation engine, or multiple data sources. These applications often require data warehousing, glue code, lots of iteration, and lots of frustration. The Exaptive Studio is a rapid application development studio optimized for data projects. It minimizes the code required to build data-rich web applications and maximizes your time spent on your expertise. Go to exaptive.com/SEDaily to get a free account today. That's exaptive.com/SEDaily. The Exaptive Studio provides a visual environment for using backend, algorithmic, and front-end components. Use the open source technologies you already use, but without having to modify the code, unless you want to, of course. Access a k-means clustering algorithm without knowing R, or use complex visualizations, even if you don't know D3. Spend your energy on the part that you know well, and less time on the other stuff. Build faster and create better. Go to exaptive.com/SEDaily for a free account. Thanks to Exaptive for being a new sponsor of Software Engineering Daily. It's a pleasure to have you on board as a new sponsor. Speed is certainly something that's great to have, but there are lots of other problems to solve, and we're going to get to those. I mean, that's why Realm is a database framework. It is solving a lot of problems. The first thing is the speed, though. What contributes to that speed increase? Why is the Realm benchmark able to be so much faster than the alternatives?
Yeah, well, I mean, basically because we started from scratch, understanding how modern processors works, how important it is that you are very, very efficient with your memory and the memory layout. If you look back, there are some cool graphs, which obviously on this podcast is pretty difficult to show. But when you see the speed difference between or the performance difference between memory access and CPU. That could at one point maybe be 1-to-1, but these days there's a huge speed difference between memory and CPUs. So CPUs have gone up very much in performance, whereas memory hasn't. So that big gap just means that the only thing you need to concentrate on is your memory layout. Forget anything about CPU performance and how many instructions you need to crunch through. You should only concentrate on memory layout, and then you can gain a tremendous speed improvement. So so that's why Realm was built up as a column store, basically making sure that things are in columns, so that your individual properties, like say you are searching for a name and you have different name, age, address, and so on. If you lay that out in memory, like an old programming language would do, you would continuously jump over memory if you are actually searching for the name to be something, right? And that's where column databases, they put the names after each other, which means it's very simple to search through the name. It's very efficient because the processor will ensure that when you pick up memory, you will have the cache will be very efficient. So some of those things, thinking about that from the ground up, making sure that speed was the number one thing when we started, and continuously optimizing that, utilizing the new instructions that are in modern processors. That just gave us a very, very big head start. So the original raw core database in C++ was just turned out to be 1,000 times faster than SQLite, which was tremendous, right? But the thing is that as engineers, that's just so fun to do, right? It's just so fun tweaking all that stuff. But then you realize, that that's not everything.
Well, the column orientation is pretty cool. It's fascinating because my sense of the historical nature of the columnar databases, this is something that started getting popular to deal with quote unquote big data, like things like Cassandra, and it's interesting to see that propagate to the consumer side of things. Like you actually want this in your phone's database too.
I mean, and the other thing is working. I mean, when you then think it through and say, okay, so data really has, the size of data, the amount of memory you chunk through, that's the most important part. Then you think about, okay, in other databases, you have to specify what size is your integers or your numbers, right? And it could be a bit, it could be a 64-bit, but you have to specify it up front. And we just thought that is really, really not interesting. First of all, you don't know in advance, and sometimes it changes, and then you have to migrate your data, and it's just awful. So why not just make an integer that can actually be up to 64-bit, but could also, if the numbers are really small, and they usually are, like an age has some kind of limit usually, then we made this compressible integers so that, a bit takes up a bit if there's only a bit in it, and just use the amount of memory necessary, which just means that it's really, tight and very, very fast into searching.
Let's go into the technical depths of the Realm mobile database, and then we will zoom out and talk about the framework and the higher level things that you're solving. At its core, the Realm mobile database is in C++. Every mobile platform runs that C++ core and connects to it using Objective-C or Swift or Java or any other mobile platform that you're compatible with. Describe what the responsibilities of that C++ core are and why or how it interfaces with the other languages.
Yeah, so obviously we chose AC language to make sure that we could actually have one core that would work efficiently and then interface to other languages, because we knew from the beginning we were going to interface to other languages. And C and C++ is basically the most efficient way to do that. So at its essence, the core database basically stores, properties in compressible form. It's searchable without doing any kind of sort of deep decompression, and then it provides a number of other features around that. Obviously, the first one that was that we wanted it to be a completely ACID compatible database, so it has transactions, read and write transactions, and then it also uses multi-version concurrency control to ensure that you can actually perform a lot of reads at the same time as you're doing writes without having a huge memory overhead. And that's super efficient, and works great. So then, that's basically it, right? Then you have obviously other features like encryption and stuff like that we apply on top of that.
Yeah.
But that's the essence of it. Yeah.
Right. Okay. So, is there anything worth noting to any interesting innovations you need to make on covering how transactions work, just in terms of the mobile database? Any interesting properties of read, write, delete, anything else?
Yeah, one of the things that we really want to try and make things easy, right, and easy to how shall I say, to comprehend and work with. So one of the things we did was that we said, okay, we only have one write transaction at a time. It will basically block another write transaction. It makes it very easy for you to reason about what happens, right? And nothing happens in parallel. Now, we're skipping sync for this moment, but so only one write at a time. That is simple. We have to have as many readers as possible. It's a multi-threaded design, obviously, and that just has to work well. So any mobile app is multi-threaded, right? So, one of the biggest things about doing any kind of ACID completely trustful database is that you need to be able to trust when actually data is written to disk or SSD or whatever. And I think there we actually were caught by some surprises to figure out that some of the operating systems are not necessarily behaving all that nice. So it can be quite costly to actually commit things to disk. And when you do a sync to disk and ensure that data is actually written before you actually return from your write transaction, if you need to do, you have to do that in a way where it is impossible for any, if your phone dies at any instruction, right? It just has to be completely crash safe.
Yeah. Byzantine fault tolerant.
Yeah. So that means you just have to do two things just for one transactions. And that is really costly. But that's something we chose to do to make it absolutely, reliable. So, and at the time between one sync and the other sync, you basically just move one bit to indicate that you have moved in multi-version concurrency control. You basically have, two pointers, one for the new data, one for the old data, and you basically move that pointer with just one instruction that has to be completely atomic, and either it executes or it don't. Sure. So those are some of the things, but working with that, you just discover that some operating systems don't necessarily perform a full sync when you actually request it.
Yeah, and so I want to get into the sync stuff, the higher level features, the stuff that is with the mobile device interacting with the cloud. Just as a side note, people who didn't understand some of the terms that Brian just mentioned, we did a couple shows a while ago about Uber and their movement between MySQL and Postgres and back to MySQL, and we went into depth of multi-version concurrency control, how that works, why it's mandatory for a database. But let's get into the higher level features of Realm. So Realm is a database framework, as we mentioned. What does that mean? What were your goals with making a database framework?
Yeah, so I mean, there are many things besides the raw storing data that matters. I mean, let's get a bit back to the framework thing, but just before that, the important part for us was to make it seamless, like a part of the language, right? So instead of having a normal database where you copy data in and copy it out again, what was really useful in our perception was, just treat the programming language, as an integral part of or the database as an integral part of the programming language. And stepping back a little bit here, that was some of the original ideas, that you shouldn't be able to even see that it was a database, right? Obviously, then the thing comes with how do you actually make transactions. So it has to be a little transparent that you are actually storing data. But that's sort of the thing that is very, very different with Realm, is that the second you touch your properties, you are operating in the database itself. So there's no copying data out. So, and you can ask, is that a part of a framework or just an integration into the language? I don't know. That's probably a matter of definition. But it's anyway something that you can say that the ORMs that you have put on top of databases in the past has basically tried to solve that, impedance mismatch between a database and objects. Now that is the first layer of I don't know if you want to call that a framework, but it's at least the first layer of integrating it into the language. Now the ORMs just have trouble doing things in a good and nice way because they don't have a deep integration into the database. So it is basically a band-aid on top of it. So because we can actually just make the database in any way we want, it's possible to make that integration really smooth. And the thing about making apps today where you really want apps to be reactive, having events when changes happens to your data is very, very useful. And that's something that's very, very simple to make when you can actually create those events when you want, and because you own the database. Now, on top of that, obviously comes other features like syncing out and other components that people build on top of that. But that's another thing, yeah.
Well, let's talk about that sync. Realm has an automatic sync with the cloud. I know this is a complex distributed systems problem. Give it a high level. What is a strategy for syncing with the cloud? And I mean, I think this, along with this goes there's this term real time. It's a real time sync. Real time can mean a lot of different things because there's always going to be some amount of latency. So it's kind of a question of how real time is it. So maybe you could just give an outline for how you think about that automatic sync.
Yeah, so I mean, taking it back to the programming language again, where the programmer is sitting and having this huge problem of how to deal with sync. One of the first things we heard when we launched the database was, it was probably one of the first, issues that came up on GitHub. What about sync? How do we deal with that? And we were actually already working on that at the time, but doing sync probably is a huge undertaking. It's a huge undertaking to make a mobile database. We've been 5 years working on that now. And doing sync is also a very, very huge part of it. But it was, built in and designed from the beginning, so we knew where we were going with this. It was a bit difficult to not talk about it, but we wanted to give it the time that it takes to actually make it work properly. So you can say the main goal with sync was that it should be totally transparent, right? You could, as a developer, you shouldn't worry about it. We basically want to completely remove that big overhead in terms of programming effort that is in dealing with the networking. It's like that fundamental idea that you just have objects, and objects is your data. It is connected to your database somehow. You don't need to deal with it. But these objects, instead of just being easy to share between threads, it should be just as easy to share those objects between any device or a server or another, mobile device. It should be completely transparent. And that was a big idea with this, or aim, that you don't see it as being transferred anywhere. It's just immediately available anywhere that you want it to be available. So that was this design philosophy about it. And that's obviously a little difficult, but you can see in our APIs today,
to say the least.
Today, if you actually want to enable sync, if you've just been using Realm for any thing, the only difference between syncing it and not syncing it is just setting up just a configuration in the beginning of your app, right? And then you won't be able to see the difference whether an object is updated on one thread in your app, or it's updated on another thread in another device or on a server. You can't see the difference. You only you just get an event when the data is updated, and that's it.
So people who may be wondering, why is this real-time sync so useful? I think about an application like Dropbox, where you've just got files and you want to have them synced with the cloud. And I remember when Dropbox came out, you hear Steve Jobs say, "Oh, Dropbox is a feature." And it turns out, no, actually, this is a really hard company to build, and Google can't do it, Apple can't do it. Dropbox did it. Dropbox did it really well. They continue to do it. It seems like they're continuing to build an entire business off of basically syncing. There are some canonical application patterns that look a lot like syncing, and you're trying to solve those. You want to be able to enable people to have real-time communication. You want to make it really easy to build messaging applications. You want people to be able to know, if a user is using their app, is that person online right now? How do you track user state? And sessions are a hard problem. I've done some shows about Google. Google's got this streaming thing, Google Dataflow and Apache Beam, and they use state user session tracking as an example of this is actually a really hard problem, because when does a session begin and end? It's kind of subjective. And so Realm, in the real-time sync problem set, has many applications that it could potentially solve. How does Realm enable these sets of, if we think from a high level, from the top-down perspective, messaging, tracking user sessions, how does Realm enable these kinds of applications, and what design decisions does that translate to at a lower level?
Yeah, so the thing is that as soon as you have basically an open connection, technically we're just using WebSockets underneath for the transportation, right? So you basically have an open connection, and that obviously has a lot of advantages in terms of not having to comparing to a REST API, where you basically transmitting a lot of more data and having to open connections all the time. But so that's one part of it. The other is that when you want to build those kind of applications, it should obviously be very, very easy. And having this object API, where you just update an object, and that object is just transmitted to a server that would populate that out to whoever else is want to know about these objects, just makes it super simple to make those kind of apps. It's basically trivial. We're having a feature coming out very soon that basically is Google Docs in a property, right? So you can have a text string that will work like Google Docs. So not only will you have enable the messaging like you would normally do. Let's say now I write something, you might be able to see that I'm typing, but you can't see what I'm typing because it's not really cooperative. It's just indicating something is happening in the other end. But very, very soon we'll have this out so that you can actually see real time I'm typing. You have Google Docs in a basic in a field.
See, it's incredible, and I've done a couple shows with developers from Meteor, and Meteor, this JavaScript framework, I've so I looked at what is their real-time story for a while, and this real-time stuff is the potential for applications that we could build. I think is really an untapped world. We're seeing the early days. We obviously saw the earliest days in terms of Google Docs, and that's really cool that you're now democratizing this sort of thing. It's certainly fascinating that you think about Google Docs. That was made, like 8 or 10 years ago, and we're kind of just now... I mean, it still feels like real-timeness has not been totally democratized. You see Uber, and you're looking at you're in San Francisco with great connectivity, and you're looking at an Uber map, and it's still like the car is like sliding around in these weird ways, and it's like not really working as you would expect a real-time, like quote unquote real-time system to work. And I mean, I've done shows with Uber, and I talked to them about it. It's like their real-time sync problem is tremendously hard because you've got a driver with a smartphone that's got constant GPS updates. You've got a rider who is looking on their phone at the constant GPS updates, and it's a lot of data, a lot of synchronization, flappy networks. We've got a long way to go.
Yeah. I mean, I think we're just at the beginning of this, right? It's. I mean, one of the reasons is that it is so damn hard, honestly. We've spent years and years on years on this. It's hard to think about. It seems so simple when you start out on it. You say, oh, we'll just do like this and this, right? But before you have it working, you've spent several man years. And the reality is, today, if you're not fast in doing your apps, you're dead, right? You can't spend years doing apps, right? So you got to do what you can with the resources you have. And very, very few companies are able to do it and have the resources to do it. Now, this is something we just concentrate on to make right. So this is, what we try to be good at. And make that available, to developers in a way that just makes it trivial for them is sort of our goal. Now, talking about Google Docs and our syncing, it's some of the fundamental technology and theories this has been built on is operational transform. So it has relations to the developments that has been done there.
Operational transforms?
Yeah.
What is that?
Yeah, that is what that's the algorithm that is that Google Wave originally was built on. It's old
Google
theoretical.
Wave, wow.
Yeah, and that is also what Google Docs uses today. It is basically tracking operations and transforming them. It will be another show if we have to go into the details of that.
Oh, okay, all right.
But you can look it up. Operational transform. That's basically how most of the collaborative editing works today. Now the problem with that was that it is mostly described in the lecture or the documents and the research papers as dealing with actually text, and we had to sort of extend this to deal with complex structured data, so that we spent a bit of time on that.
Indeed Prime flips the typical model of job search and makes it easy to apply to multiple jobs and get multiple offers. Indeed Prime simplifies your job search and helps you land that ideal software engineering position from companies like Facebook or Uber or Dropbox. Candidates get immediate exposure to top companies with just one simple application to Indeed Prime. And the companies on Prime's exclusive platform message the candidates with salary and equity upfront. Indeed Prime is 100% free for candidates. There are no strings attached. Sign up now and help support Software Engineering Daily by going to Indeed.com/SEDaily. That's Indeed.com/SEDaily if you're looking for a job and want a simpler job search experience. You can also put money in your pocket by referring your friends and colleagues. Refer a software engineer to the platform and get $200 when they get contacted by a company, and $2,000 when they accept a job through Prime. You can learn more about this at indeed.com/prime/referral. That's indeed.com/prime/referral for the Indeed referral program. Thanks to Indeed for being a continued sponsor of Software Engineering Daily. If I ever leave the podcasting world and need to find a job once again, Indeed Prime will be my first stop. There is also an emphasis on being able to interact with third-party APIs within the Realm documentation. I'm looking at it. I think of things like Stripe or Twilio. The quote-unquote API economy it's getting big, and these things make it so much easier to build applications. I mean, this is just tremendous leverage for developers. I'm curious why does that affect the architecture of what your database framework is? Why does the third-party API economy affect that?
Why it affects it?
Because I think of a database. I think of a database as a very different. I don't think of the database as being at all related to third-party APIs, but I see mention of it in the documentation. Like, I don't know. Maybe I'm.
Yeah, so maybe I'm missing out on the point here because obviously third-party APIs in terms of Stripe and those. We're really not interacting with them in any way, right? So what we're sort of trying to replace is usually the APIs you build yourself, right? Because enterprises that has legacy databases, obviously everybody has that today, unless you're a startup, right? You have something built already, right? And you need to be able to integrate somehow to that part, because otherwise, it's hard to get in there. Okay, well, this is my next question. Yeah, throw out all your existing databases, and people will look at you. Yeah, can I trust that? Right? That's just horrendous. So on the syncing side, you should really look at Realm, at least initially, if you don't have any, or if you have existing data, that you basically build a front end to your mobiles, right? And that just means that all that horrible REST APIs that you have out in your mobile, you can scrap that. You don't have to build it, first of all, both for Android and for iOS. Now you can get rid of all that, and then you can just concentrate on a REST API from your backend to the Realm mobile platform, which makes it much simpler, and all those REST APIs will go much faster. And you can skip all that error handling that you usually need to deal with when connections drop and come back on and all that stuff.
Can you talk more about the legacy integration problem? Like, if I'm some old company, I've got a ton of data, I've got various databases, what am I doing to integrate with Realm?
Yeah, so right now at the backend side of things, we have a JavaScript API. It works completely similar to our other APIs. It is roughly the same, you can say. If you look at our React Native API, and we recently launched just the JavaScript framework as a separate product, so you can even use it just for pure JavaScript on the backend if you want to, in Node. And then that part of it works with objects just as you're used to with any other product from us. And the simplicity of that is working with objects, getting events whenever something happens. Now that works pretty well because when you're sitting on the back end there, and you can basically just observe any kind of object on any device you have. So let's say you have one Realm file that could be sharing state to, let's say, all your devices. Let's say you just want to share some common state, right? Then you would be changing your object in your Node app, and that object will just be transmitted to all your devices. And the thing is that then you can, in Node, you could basically interact with all your backend stuff, whatever way you want it. Let's say some of that data gets updated, you would just update your object in Realm. Now, to make that easier for you, we're building connectors to specific databases and also some generic APIs, so that it will be simple for you to integrate with your other databases and sync up data to whatever legacy database you have.
I want to zoom out and talk about the business model and the developer ecosystem, because RealmDB is an open source project mostly, I think. Can you describe the relationship between the open source community and the business model and how that all works?
Yeah, I mean, originally when we thought about what to do in this space, first of all, we all like open source, so we actually just wanted to have that. But secondly, from a business perspective, when you come out with something new and you need some kind of adoption, one of the things that really ticks developers is open source, right? In particular, things like a database, you want to know that it works well. You want to be able to actually continue using it, even if that company that created it suddenly should disappear. So that's some of the big advantages you have with open source, right? And then the other thing was that, at the time, SQLite is free. Apple provide core data for free. All the alternatives are free. So it's pretty difficult to come out with a paid product in that space. So, and basically, we really want to make something that, developers love, and we want to broaden that out to everyone. And that's only one way, and that is to give it away for free. Now, then you have to build your business around something else, obviously. And for us, that is this synchronization framework that enables us to solve a very, very, very large problem that a lot of companies are fighting with, and that that we get feedback on is something they spent years and years on without even solving properly. So that's obviously something that has a huge value to corporations. Now, on the other side, we're very, very, involved in the open source community and in developers, and, the hundreds of thousands of developers that are using our products. We don't want to, just not give anything to them. So that's why we're also actually providing the mobile platform with the syncing and all that for free. And just reserving the most enterprise features, for payment from corporations. Yeah.
What are the challenges to building a successful company around developer tools? Because we saw this RethinkDB situation recently. RethinkDB, very cool product. I had Slava of RethinkDB on the show. We talked about RethinkDB. There are inherent challenges to building developer tools companies, especially this precarious line where you're walking a lot of times the software business, like you think about Windows 95, what a great business, because it's not open source free operating systems. It's, proprietary software that they sell for $100 and print on a 12-cent CD. It's a lot different than the economics of an open source database solution. So tell me about the difficulties of building a developer tools business.
Yeah, I mean, I don't know if that many have been successful with it yet, right? So, I mean, that's something we are trying to learn, and obviously learn from all the others that hasn't been successful with it. But I mean, I think it's from the start on, you need to have something that is something that differentiates. You need to have give some real value to people, and then you can argue that it is very, very difficult for people, and I'm a little surprised actually how much developers as developers we're spoiled, right, with developer tools. Honestly, these days, right, we get everything for free. I mean, and there are hundreds of man years of work behind all that stuff, right? It's amazing. So that obviously also generates a lot of developers, because it's pretty easy to get started. but yeah, it is a big problem to actually find a business model that works. Because you got to give things away for free. It has to be open source, right? And unless it has the right open source licenses and very permissive, people don't want to use it, and so you really have to give a lot of stuff away for free. It's I don't know if there's a silver bullet to that question. It's something that we're exploring as well. Basically we're saying here's cool stuff, here's technology.
What is
away for free to? Sorry.
What is a compelling upsell I see in the modern developer tools environment is where you offer a cloud, like if you have some kind of cloud offering where it's like, hey, we've got this great open source thing, and then there's a cloud solution that will save you 80 hours of setup and configuration and stuff, or you can create this conglomeration of stuff on top of the open source solution. Like, I think Databricks is probably going to do something similar to this with Spark, and or you just make it easier to use. But yeah, I mean, like you said, there's no silver bullet. There's probably a lot of interesting directions where you can go, but it's, I guess, a precarious world to play in.
Yeah, it is. Yeah. That's something we're, exploring we have a pretty good idea on where we want to take this, and we'll hope it'll work out. I think it will. I think at the bottom line, when you're talking to companies, they have serious problems. They are in need of speeding up. App development is not something they fully under control. It's a troublesome area because as we talked about in the beginnings, right? The expectations are so high, right? Even for internal apps, right? People don't want to deal with that junk if it doesn't work as good as everything else, right? So the expectations are really high, and if you're providing something that the corporation would normally really spend a lot of time on, they're willing to pay as well. It's not they can see they will save a few man years on that. So I think that's worth it, right?
For sure. So when you think about the problems you're solving as a mobile database, is this going to be the database for IoT and drones, and does it have applications for cars? What are your thoughts on where this goes in the future when mobile doesn't just mean the piece of glass in your pocket, but it also means your wearable and your, all kinds of other things?
Yeah, I don't see an end to where this could go, honestly, because exactly all those new applications have the same requirements, like maybe the space requirements and CPU requirements are not that low anymore, right? There's quite an abundance of CPU power for almost no cost, even in small IoT devices. So sure, you need. There is no app without data. We always need to work with data, and that's what we're trying to make very, very simple. And like say virtual reality or things like that. You have this thing about you need quick update speeds, or otherwise you get all dizzy and things like that. Your access to data just has to be fast, but more importantly, all that development goes at an unprecedented pace. That is mind-boggling, and that just means that if you can save development time, that is really, really crucial for your business. So that's what we are trying to do. Basically, make sure that people can save a lot of time and also make better apps. Because I just spoke to a customer the other day and then asked, well, so what is it really that you've sort of gotten out of this? And that was a customer who'd been very reluctant to actually get started on Realm because they were quite happy with what they had. But then when they did, they said, well, wow, we just saved ourselves tons of testing time, because now we don't have all these, different objects that are out of sync with each other, and we have all these weird edge cases with our testing, where it doesn't work when we go from one list view down to some sub view and go back again, and something is not updated because now we just have one state it's always, we know what it is. And if it's changing, we get an event. That just saved them so much time in the end, so they were just very, very happy about that particular corner part of it. But it's the bottom line, I think, is, developer productivity is very, very important for most businesses.
What are the problems in mobile databases that you feel like you haven't been able to tackle yet?
Well, I don't know if we have any particular big problems. There's tons of things that we would like to do. There's tons of areas where you can look at our GitHub issue list, right? That's all our development there is totally public and in the open. So we have a long backlog of things we want to do even better, right? So in particular, probably in some of the search areas and geospatial, indexing, things like that, where that's something that a lot of apps are using. Not too many, but most are getting that direction to some extent. Some of those areas where we can make it much easier as well.
Right. So these are like situations where people right now have to do polyglot sort of stuff, where it's they have the maybe InfluxDB for their time series component, and they use Elasticsearch for their search component, and it'd be cooler to have that stuff bundled into a single database.
Yeah, it sure would, and there's also, the component side. We have explored that to some extent, but mostly that has been, from the community, basically building out, a maps component. So you just plug in a map, and it's super easy to,
wow.
have it already backed up by your data, right?
Oh, cool.
And or a search functionality, where you just start typing and you have all your completions and all that stuff. Well, that's just plugging in a component and then it works. I think that's an area we could do much more, honestly.
Okay.
Always some good, cool parts have been done, but we've been very focused on the getting the mobile platform ready here lately. So.
All right, well, Brian, I want to thank you for coming on the show. This has been a really good show, and many people had requested RealmDB, so I'm really happy to have had you on. I know I guess we mostly skated along the high level, but I know there's a lot of interesting technical details, and people can go and check out documentation or some good videos and stuff. And thanks for coming on the show. Yeah, well, it was a great pleasure to be. Thank you for taking me on the show. Thanks to Symfano for sponsoring Software Engineering Daily. Symfano is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symfano.com/sedaily. That's symphono.com/sedaily. Thanks again, Symfano. Wow.